So this video is going to go through the homework that was given in today's class. So it shows a hemisphere and a cylinder. So the elevation of cylinder A and hemisphere B in contact with each other and are both resting on the horizontal plane. A sphere of 50 mm diameter is placed in position C. So it's going to be a third object, a sphere, put in position there. And the sphere is to be in contact with the other two solids and the horizontal plane as well. Draw the plan and elevation of the solids showing all points of contact. So the first thing we want to do is draw out the elevation and plan of what we currently have. So always starting off, I'm going to draw my XY line there. The elevation of the cylinder is a diameter of 66. And then the radius of that would be 33. That down from your plan. And the height of it is a total of 75. So for now, I'm going to draw everything in lightly because it's going to be some objects that are going to be overlapping. Then for the hemisphere, we're going to go out 15 and it's going to be a radius of 40 for the hemisphere. And we can see from the question the hemisphere is sitting in front of the cylinder, hence the hidden detail in the question. So that's our elevation. So what we want to get now is the plan view of these two objects. So first of all, I'm going to take down my two centers. And I'm going to have the center of the cylinder at that there, and that is going to be a radius of 33. So in plan, we're going to see our cylinder as a circle, and then the hemisphere is going to be slightly in front of it. So what we can do is we can take that hemisphere. There's two ways we can do it. First of all, we can do what we kind of been doing in class, where we move the object to the side of it. So what we would do is very simply take our radius 40 and mark it from the edge of the cylinder. And what that would do then is that would move that hemisphere into that position there. And what we could do is we could take that center down, the new center, and we can rotate it into position. There's our original center, so it's along there. We can rotate it around like that and take our radius 40, as so, and swing it like this. So I'll just try and move this a bit closer so you can see the very bottom of it. So I won't be able to move it any lower with the phone set up the way it is on the stand. But that's the plan view there of it. So that's one way you could do it. The other way you can do it is you can add the radii together. So if you take the radius of the cylinder and you add it to the radius of the hemisphere and swing it around, where it would hit that line would also give you the exact same result as well. So it's basically the same as taking like our edge view. When you add the two together, which would be the distance from here to here, plus the 40, that would also give the same result. So you wouldn't have to draw that as well. But if you find it easy that way to create an edge view first and take it down and around, that's perfectly fine as well. So I'm just showing you a visual representation of what we're actually doing by rotating it around. So to find the point of contact between those two objects, we join our centres. So when you join the centre of two circles, the point of contact lies along it. That's the point of contact between the the cylinder and the hemisphere. To find that point of contact in elevation, we take it up, and because they're both resting on the ground and their point of contact, you can see in the edge view is on the ground, that point of contact is going to be there for the two objects. Now what we want to do is draw in the sphere. So just like we would have done in previous questions, the sphere is a diameter of 50, so it's a radius 25. We know it's resting on the horizontal plane, so that means the centre of that sphere is going to be 25 mil above the ground at all times. So I could take like a light line across like that, 25 mil always above the ground. Now, just like we did in the earlier question in class, we're going to create an edge view of where that sphere is touching off both objects and roll that sphere around into position. So if I start off with the cylinder here, I'm going to go 25 mil away from here. So imagine that sphere is always 25 mil away from the edge of that cylinder. So basically you're drawing parallel lines, just like we did with the ground there with the horizontal plane. So that is the centre of that sphere when it's resting side by side with the cylinder. We take the centre down, and what we're going to do is we're going to rotate that around, and it's going to be somewhere along that arc there. We're going to do the exact same now with the hemisphere. So this is the hemisphere now in the correct position. So what we're going to do is draw the sphere resting against that. So once again, it's 25 mil off the ground. And what I'm going to do is I'm going to add a radius of 25 onto the radius of the hemisphere. So the radius of the hemisphere is already 40. 40 plus 25 gives me 65. So I'm going to take a radius of 65, and I'm going to swing an arc from my centre of my sphere or hemisphere, which is in the correct position. And that crosses over, giving me that point there. If I join the centres, the point of contact is going to lie along it, and that's where it's going to be in contact. So I can now take as my radius 25, which is going to be that distance there. So there's that sphere as an edge view with the hemisphere. I'm going to do the exact same thing again. I'm going to take it down into my plan. I have to remember now, I'm not taking in line with the the cylinder. I'm taking in line with the hemisphere in plan. So I'm going to be taking this radius and rotating it around. So that'll go around, eventually it'll come around the other side, and it'll cross over at that point there. And that gives me the center point of the sphere that is touching off both the hemisphere and the cylinder. So I'll take that radius 25, and I can now draw my sphere in position. Like that there. Now the points of contact. First point of contact that I have is between the sphere and the cylinder. That's the point of contact as an edge view. So when I follow that down, it goes around and it's going to be somewhere along that arc there. Now I know once again, the point of contact lies along the center of two circles. That's a circle there representing the sphere, that's a circle there representing the cylinder. If I join those centers, that gives me my point of contact in plan. One more thing I actually forgot to do as well is actually draw that sphere in the correct position now up here. So I just take the center up, and once again I'm drawing my sphere, which is now in the correct position. So, point of contact is in plan. I'm now going to take that point of contact up. We know the height is there. We take that height across. That gives me the point of contact between the sphere and the cylinder. The other point of contact then I want to find is between the hemisphere and the sphere. So as an edge view, that's where the point of contact appears. I want to take that down and rotate that into its correct position. So I take that radius there, I swing an arc around, and what I want to do then is I want to join once again my two circles. And where they cross over is that point there, and that gives me my point of contact in plan. In elevation, I simply just take it straight up and take my height across, and that gives me my point of contact there in my elevation. And they are all the points of contact I need. The last thing I'm going to do then is I'm going to just draw in heavy everything that I want, and then hidden detail then for what I can't see. So I'm just going to pause it there, and I'm going to go over it all in heavy, and I'm going to move this down a little bit so you can see. So that is the finished question there, shown in heavy and the hidden detail, how the objects actually look when they're all joined together. So hopefully that video helps anyone who may have been stuck on that.